Okay, so would you mind giving like a 1 minute intro about who you are and like what you're studying and stuff?
Yeah, so hello, I'm Dikshit Reddy. I'm a CSE final year student from Hyderabad, India, and uh, I've been preparing for Mang interviews and targeting Mang roles.
Cool. Okay, sounds good. So we're gonna have 45 minutes to do two questions here. So we're gonna stop at 7:30 PST.
Yeah,
So you can watch your own time and just make sure like I'll give you like a time update, but you should watch your own time. Make sure you know we have two questions. Okay.
yeah. It's
So
45 minutes from right now, right?
45 from now. Yes.
Yeah,
Okay. So basically, you in the first one, you're given an array of books. So let me actually paste this stuff. So you're given an array of books and a shelf width, and the books have a width and a height, and a shelf width is like what's the total width you can place on one shelf. And what I want you to do is place the books in a way where the total height of all shelves is minimized. And the height of a shelf is basically the height of the highest book on the shelf. So if like one book is height 100, the rest are like height 2, that shelf is 100. So in this case, I can place book 1 by itself. Then I can place book 2 and 3, and then I can place 4, 5, 6, 7. So book 1 would fit on the shelf, and it's height 1. Book 2 and 3 are both height 3, so this is 3. And they would fit because they occupy four total. And the last four books are 1, 1, 1, 2, so the height would be 2, and they also occupy 4. So the total height here equals 6. So feel free to ask me anything you want to, any clarifying questions or anything like that.
okay. Uh, so just to restate the problem so that I could understand it better, we are given Booksari and uh, the zeroth index represents the width and first index represents the height, and we are also given the shelf width, and we are supposed to place the books uh, horizontally first and make sure it doesn't exceed the shelf width, and then place them vertically, and we are supposed to find the minimum height uh, that we can achieve.
Yes.
Okay, so we are supposed to place all the books, right?
Yes, all the books. And they have to be
And
placed in the same order that they're given. You can't move them around.
okay. Oh, I have to place them in the same order that they're given.
Mm-hmm.
Okay. Who? Okay. Yeah. Thinking about it, uh, I would first think of it in a greedy way. Uh, if I could solve it.
Mm-hmm.
If it doesn't, if greedy fails, I would think about recursion.
Okay.
So since we have to place it in the order that, are we supposed to return the um, end matrix, the order that we placed?
No, you just need to return the height.
Okay, just the height. Um, so we place uh, the first book here and check the width height. Uh, yeah, since if the order should be maintained, then I think we can just check the next book's width if it is possible to fit in something like a greedy approach, where we check the next book's width, and if it's possible to fit in the same row, we would fit in. If not, we would uh, go to the next row.
Okay. So if you actually look, what would you get greedy for this one? If you do greedy for the example I gave.
Uh, I'm sorry, what?
So if you try greedy with the example I gave, what answer would you get?
Okay, so uh, I have the first book, and my shelf width is 4. So it's lying. Uh, I have no books placed in the current row, so the width is 4. And now that I added, I subtract 1, so the current shelf width would be 3. And then we check the next one. So it's now I have a doubt. Uh, Actually, I'm looking at the wrong widths and heights. I'm sorry.
Okay.
Uh, I was considering it as height into width.
Oh, okay, sure.
So we have a 1. We placed 1.
Mm-hmm.
So why aren't we placing 2 in the same row?
Yeah, so why don't you try that and then see what you get?
Okay. So we have 1 and then 2. We still have uh, 1 more left, so we cannot place the next one.
Mm-hmm.
Here the max height would be 3.
Mm-hmm.
Okay, so yeah, it makes sense. So we are sacrificing height to fit in the rows. So I think
Mm-hmm.
greedy would fail here.
Yeah.
Okay, it makes sense. So we have to, yeah, I think it's recursion that I could think of.
Okay.
Uh, so we would start off from books 0 index, and then it's like I'm thinking of pick and not pick. So if I choose to pick uh, the current row, whether I should place it or not, or go to the next height, basically to the next level.
Okay, so
And
every basically you're saying like every book you're gonna say place it on like the current level or the next level?
yes,
Okay.
before placing it, I would ensure that it's within the width itself.
Okay. And so what would this look like? Like what would be the time and the space and how are you maintaining like the max height of the shelf if you do it like that?
Okay, so mm, okay, we have two options here. So it's whether to pick or not pick. So it would be the time complexity would be 2 power n here,
Mm-hmm.
and uh, so the height we could um, we could say at the end of the if we reach the end of the array, we could return 0.
Mm-hmm.
When we are recursing it, we can uh, add more levels to it. So it's kind of like a DP problem.
I see. So you said it's 2 power n. So can we get
Y-
it down from 2 power n? Because 2
Yeah,
power n wouldn't be very good.
yes, we could memorize it and then later convert it into tabulation form.
Okay, and if we memorize, then what will be the time complexity?
If we memorize it, it would be n, and the space would be n. N plus n. So basically, we are having the. Okay, let me think about the states real quick.
Sure.
Uh, we are the states that we are working with is uh, index for sure, and we are not considering the height because that's the answer the function would be returning. Um, and I think the current width of the row 2 would be a state.
The current width of the row.
Yes, because
Okay.
uh, uh, we would have to know the current width of the row, or we could place them in a loop. Uh, no, actually, width would also be a state. Current width of the row would also be the state along with the index.
Okay. So if you so you're basically storing the current You're storing the index and the current width of the row, and that would be
So
what time complexity?
it would be um, the DP would be in terms of 2D array, so it's n, and then the max would be 4, so 4n for the time space complexity, plus the recursion stack would be n, and the time clock complexity would be big of n.
Okay, well the shelf width doesn't have to be 4, right? It can be like a million.
E- Then yeah, it would be shelf width into n,
Okay.
shelf width into books.
Okay, and how are we gonna get the height? So like, if we have a take or not take where we place on the shelf or not, how do we know what the height of a shelf is?
Um, I'm sorry. So, how are we going to find the answer? Here's what.
Yeah, so when you place things on the shelf, right? Like, let's say I
Yes.
place like some items. Maybe I placed like, well, I don't know, like 1, 2, and 3, and I'm on, or I placed 1 and 2 on a shelf, and I'm like, okay, well I'm on 3. Should I add it or not? Like once I'm done adding to a shelf, I need to know what's the height of that shelf, right? Because the total height is height of
Okay.
all the shelves. So if you're doing take or not take, how do you know like what's the height of the shelf currently or whenever you're done?
Okay. Yeah, it makes sense. So, yeah, I was thinking if we could place the entire the possible items, but it wouldn't work because okay, we have to place them in order. So it's like either either place it or don't place it at all. It's not like we can um okay, if we place it, okay, I think there are three possibilities to this.
Mm-hmm.
One would be, place the book. The other would be don't place the book. Okay, we should place the book at all costs. It just has to be in the next row.
Mm-hmm.
So it's not like not place the book. Rather, it's just increase go to the next level where you can place it.
Yeah, so I agree. So maybe you like add the shelf width or something. But my point is like, if I have like 5 books, like how do I know once I'm done placing books on a shelf? How do I know what's the height of that shelf? If every call is in a separate recursive call, if every place is in a separate recursive call, like how do I know that? Does that make sense?
Yeah, I mean, during the recursion call itself, we would keep adding the max height of the shelf so that we have a count of that
And where would we add that?
uh, before the call to the next level itself. We maintain the max height of the book in the recursion call, and before taking the min and before the recursion call, we add the height plus, let's say, recursive function call of books.
Okay. Okay, I guess we'll just see the implementation details. So I think I'm good with this. So basically you said this is going to be n times the shelf width, right?
But yeah,
Okay, and the space is going to be n times the shelf width as well.
yes, plus the recursion stack, and later if we tabulate it, that would eliminate as well.
Cool. Okay. Yeah, I think we can get to coding then. I think I'm good with this.
Okay. Should I just write the function? Or-
Oh yeah, you can write the function since we're not coding. You can just write the function. That's fine.
Okay.
So you can just take a function that takes in the books from the shelf width, and you don't need to call it or anything. You can get rid of the main
Okay.
too if you want.
Yeah, it's fine. Okay, I have to import the vector.
Cool.
Okay, now we have the books and shelf width. So we are doing recursion. So we would start off with uh, books 0, the index 0. So index n is equals to 0, and the current width would be 0 as well.
Okay.
And then we return solve current width. Okay, so the base condition would be
Okay, so solve is your like
that,
DP function.
yeah,
Okay,
so it's the recursive function. So
sure.
should I name it
You can call it
recurve?
whatever you want. It doesn't matter.
And if index is basically books dot size, we would return 0.
Mm-hmm.
And then what we are going to do is we are going to place, we have uh, one option to place it in the current uh, row. Okay, we can choose to place in the current row and move forward, or we could choose place 2 and go to the next row.
Okay.
So I would loop it. Uh, I would take the current while current width is less than equal to the shelf width. I can just uh, I'll maintain a max height. So basically, what we are doing is we are considering putting 1 and then 2. Uh, so we are going to call, okay. Uh, so the in current height would be books of index of 1, and current width would be books of index 0. I'll rename this as row width so that
Okay.
now we have width in the row. So max height would be max of current height, comma, max height, and then we take is equals to, this is the mini is to store the minimum height. Not sure. Okay, we have to check if the current width uh, is exceeding current width uh, is exceeding the row width. Then we can recurse in the same index with the row width as current width plus row width shelf width comma books. If it is not, then um, then what we are going to do is we are going to go to the next row. So it would be index plus one. Okay, I'm iterating wrongly here. I realized that.
Okay.
Um, so basically, we want to place as many as we can. Um, that would be a possibility. So this would to check we are placing one book and then checking the width. It's possible to place the next book too, and it would check the max height. So it's 3, and it would recurse. So far it's 1, but okay, we do not place it here. Rather, we would place it at the end. Um, and then if it is failing, what we are going to do is we are going to take for the same index itself the shelf width row width would be 0. Answer would be something like um, okay.
Okay.
So the iteration is wrong. I have to figure that out. So what we are doing is we are recursing and placing uh, one book and checking uh, if the current width plus the row width is less than equal to the shelf width, then we would place it. Um, since we only want the height, we could just add the max height here so that it does not add when we are adding to the before the recursion call it would add like one height, and then for the next call it would go 3 height. So
Okay.
rather we want to accumulate the max height in the iteration and then add the max height at the end. For
So let me stop you for a second. So we have about 20 minutes left. Would you want to continue with this problem or move on to the next?
Okay, so I would try it out for two couple of minutes. If
Okay,
I
sure.
get the iteration right, I think.
Sure.
So we have the first book. And then what we are going to do is we can maintain uh, int I variable, which is 0, which is 1. So we could do index plus I, and then the row width would be current width plus, no, uh, yeah, the row width would be plus is equals to current width. Um, Mini, and then we return the mini here. Yeah, I think this would be appropriate. Uh,
Okay, so let's just walk through this. Basically, so mini is like your result, right?
yeah, it's my result.
Okay,
So
so you get the max height, which is the max height. You get
yes,
answer, and answer is like your current recursion or something.
yeah, I think it doesn't matter because we are doing if and else, so we have to place the book. It might be right now or next, so we could just take it as answer. So that I'm just using that variable so that I could take the minimum.
Okay, so basically you're adding the current width plus the row width. If it's less,
If
then
it's
you're
less,
doing answer is add the book. Otherwise,
yes,
recurse and not add the book, right?
yes. We go to the next uh, height basically, the next row basically.
Mm-hmm. Okay.
So we would get the minimum, and then we add the max height of the current row basically.
Okay. I think this does work. Um, and yeah, we should just move on to the second one. Like, there's a bit of stuff we
Okay,
can
sure.
fix, but we don't really have time, so let's move on to the second one.
Okay, sure.
Okay. So for the second one, you have two strings. So call it like maybe A and B. And basically, so let's say the first string is like this, and the second string is like this. And what I want you to do is basically return to me the minimum length substring in A where all the characters in B occur. So in this case, it would be this because it has ABC and this is length 4. So you would return the actual substring. And
Okay.
if the substring doesn't exist, you can return the empty string. So, if this was like bank Z or something, you would return the empty string.
Okay.
So I can write that as well. So from like bank Z, return that.
No,
And here,
do
this
you
would be the
mean like
answer.
this?
Sorry. If if um if B was ABCZ, you would return the empty string like that.
Okay. Yeah, makes sense.
Okay.
Yeah, just to state the problem, so we have a string A and B, which we have to kind of pattern match, and find the minimum length substring.
Mm-hmm.
So uh, we are, since it's a substring, we are not supposed to remove any elements. And looking at the example, I think the order shouldn't matter. Just the number of characters would be crucial here.
Yeah.
So just a quick question. So there would be repeated characters, duplicate characters in B.
Yeah, there can be. Yeah.
Okay. So this seems like a sliding window problem. Uh, we would try to uh, maintain a frequency array, frequency map, and uh, okay, these are my initial thoughts. So we could try to maintain a frequency array and then decrement if we find the character that's present in B, and we do that until we ensure that the entire frequency map is zeros. Uh, it would we would increment the window as long as we get the frequency map, all the characters in it to zero. So it would be until here, and then since we've got the max length here, 1 2 3 4 5 6, we would start uh, decreasing the window so that we can find a better one.
Okay.
And when we are decreasing it, the A goes out of uh, the window, so we have to add it back into the um, map. And one thing that I'm concerned is how do we and find out that the entire map is zero, because that would create extra complexity. Um, so we have C. Yeah, in this approach, I think this could work, but uh, we have to iterate through the entire map in every window to check if the map is uh, if all the elements of B are taken or not.
Okay. So when you say like the map is zero, can you kind of like explain what you mean? So
Yeah,
like,
I can
yeah,
surely.
sure.
So we are taking character A, and the frequency would be 1 here, and
Mm-hmm.
character B, and the frequency would be 1.
Mm-hmm.
C1. Okay, let me take a different test case so that let's take two. So in my window, it would first start off with A. So this would be the initial configuration of the map,
Mm-hmm.
and um, I'm supposed to have all the characters uh, to become zero so that I have the substring B or the string B.
Okay.
So it would be A would become zero, and the window would increase. Uh, it would increase until we find a number in the map. So it would decrement in this way.
Mm-hmm.
So this could also be helpful. It's not a problem if we have two A's in the uh, substring. It's important to have all the elements of the B, all the characters of the B, right?
Mm-hmm.
So we can just check if the map is less than equal to zero. If all the elements are less than or equal to zero, then we have a valid substring. If not, there's another element that we have to consider. So the window keeps increasing as long as the map is less than or equal to zero.
And you're taking only letters that are in B, basically, in this
Yeah.
map? Okay.
Yes.
Okay.
So
So you would
uh,
get like a window like this?
yes, we would get a window like this,
Okay.
and then we would have all zeros. In fact, we would have a -1 here,
Mm-hmm.
and yeah, mm, yeah, a -1 for the A. Since we want one A, it doesn't matter if there's another A in the string, right?
Mm-hmm.
So uh, if for the next window, when we are compressing it, when we are reducing the size, this A goes out of bounds,
Mm-hmm.
it becomes 0, even then our condition is satisfying. So this map helps us uh, tell whether we have our string or not,
Mm-hmm.
and we could do a sliding window approach. So I'm concerned about the time complexity for this.
Yeah, so let's say that let's just say you are allowed to, like, we only have uppercase letters, and or yeah, uppercase letters, and it's fine. Like, basically, if it was uppercase letters, what would be the time complexity of checking the map?
Okay, so it would be 26 itself iterating through the map
Mm-hmm.
at each window. So it would be length of the time complexity would be A into 26, length of A.
Okay. Yeah, I think that's correct. So and then what would be the space?
A space would be we are only maintaining the hash map and a variable to check the max height, so it would be 26.
Cool. Okay, so let's just code this then. I think that it's fine to iterate through the map.
Okay. So I'm given string A and B, right?
Mm-hmm.
Okay. So we are going to consider an ordered map. Uh, we'll call it frequency, and I have to import starting to um, so we are going to iterate through the B and add it's just character and integer, so it's not necessary for a string. We have this is like a frequency counter,
Okay.
um, and then going to um, A, comma B, and then frequency.
Okay.
So we are going to initialize left as 0, and I think right can also be 0. Um, and we have to iterate um, through the array um, while left less than or equal to r. Um, and r is less than the size of the a. So these are the 2 pointers that we have.
Okay.
Um, and we are going to decrease the frequency of the current character,
Mm-hmm.
which would be the right pointer a of r, and then frequency of current character minus minus, and then we check the entire map basically to um, will maintain a flag if the so basically this returns a iterator, and then the second would be the value, the first would be the key. So
Okay.
if the second is less than or equal to 0, or we could say if it is greater than 0, then uh, we'll take it as true, and flag is equals to false,
Okay.
and then we break out of the loop. We this flag would tell us if we have all the elements in the uh, whether if we've got all the elements or not,
Mm-hmm.
as in so that if the all the elements are less than, all the frequency is less than or equal to 0, then we have the substring. If not, we would put the flag as false and break out of it.
Okay.
Now uh, if flag if the flag if it is true, then we consider min len is equals to um, we could take a dot size. No, actually 189. So if the uh, character is not found, we would just return the empty string.
Mm-hmm.
You wanted the string, so not the minimum length. You wanted the substring.
Yeah.
Okay. We could just take string answer. If they are of the same length, then it wouldn't uh, matter as much, or
Yeah.
is it
Yeah.
like
You
we
could
have
return
to?
any of them if they're the same. Return any of them.
Okay. So we still are going to need in len. If right minus left plus 1 is less than min length, then we are going to consider the answer to be that substring. So substring of the position would be left, and the in C++ it's not like left to right indices, rather where do we want to start and how many number of characters that we want to have. So
I
the
see.
number of characters would be r minus l plus 1. So basically, if the frequency map is uh, the flag is true, then we are considering the string and the min len to be r minus l plus 1. And then we could decrement in, um, we could do a l plus plus. Actually, if frequency dot find of a of left pointer, it's not equal to frequency dot end. So basically, we are finding if the left pointer is present or not. Since we have to compress it, we are going to do frequency of a of L plus plus and then L plus plus else R plus plus. Frequency of this would be the code.
Okay, so basically, okay, so if the flag, if this is less than min length, you do this. Okay, so what does this
Yes.
do right here?
So we are increasing the pointer. We are reducing the window after if we have found the min length. So the left pointer would move forward. Uh, when we are moving forward, if the left pointer is belonging to the frequency, then we have to increase the frequency of the character.
Oh, I
Uh,
see. Okay. Okay,
and
otherwise you increment the right?
uh, actually, it would be here. And then it's not the else of this particular thing, it's the else of flag. So
Oh, I see. So if the flag is true, if
true.
it's in
Then we,
here, you will increase the frequency and move the left up.
yes, if the flag is false, that is the substring is not present. We do not have all the characters,
Got it.
so we
Okay.
just increase the
Okay.
substring.
Yep. Okay. So let's stop here because we're already a bit over. So how do you think you did? What do you think you did well? What do you think you did badly? Yeah.
Yeah, so starting with the first problem, I could guess that it's a recursive problem and we could do a DP,
Mm-hmm.
but I was having a hard time visualizing it kind of so that I could explain it better,
Mm-hmm.
like the max height and how would we consider width. So there are like couple of parameters. So it's like a 2D DP, right?
Mm-hmm.
So I would actually, my approach would be uh, taking a pen and paper and then trying out the recursive function calls, but that would take a lot of time.
Agreed.
Like 20 minutes wouldn't be sufficient for that.
Agreed.
So yeah, that is where the code messed up totally.
Mm-hmm.
And for the second problem, I could immediately tell that it's a sliding window problem, but I wasn't sure if this map would cause a huge time complexity or if there was any better approach.
Mm-hmm.
And the way I coded it was also not that clean.
Yep. Yeah, I think I agree with all that. So let me tell you what I thought. So basically for this first one, so for DP, like yes, for like in an interview setting, you can't just be like, well, I'm gonna write out the whole tree. Like you don't have like 40
Yeah.
minutes, right? You need to kind of like understand things reasonably quickly. And so you went the wrong way where you were like, oh, it's gonna be like a take or not take, where I have the like index and then I have like the row width, I think. And so actually that wouldn't allow you to calculate the height of the row because like in every call you'd have different like books, but they'd be on the same row. So you can't return the height of the current row, you'd have to return the height of the like full thing. So that actually doesn't work and then you fixed it to make it work, but you have first of all there's a couple things, right? A, like you were going the wrong way and you fixed it. B, you went like over time. And C,
Yeah.
you have a lot of like unnecessary stuff still. So for example, like row width, like you don't need it at all because like basically what this should look like is every recursive call starts a new row. And then and then your logic is like add as much as I can and recurse at every step, right? And then figure out like what's the best there. And that's kind of what you did towards the end. But you should have realized that faster. You should have been like, oh, well, I can't calculate the height of the row if I recurse at every single point because like I'll keep adding books. So really what it should be is it should actually be it should be basically O(n) squared. And that's the other thing, like you said, like shelf width. So it should be technically O(n) squared, where for every row or for every index, add as much as I can to the row. Which you can argue like that could be like shelf width, but like the most it's going to be is O(n) squared, and then yeah, depending on like shelf width, I think it's fine. So I think I don't think this problem was like super difficult for DP. Yes, it was 2D DP, but it was like a pretty standard, I would say, template of like I just have a for loop in here. I try to test everything, and then yeah, you do what you're doing. So basically, do exactly what you did, only do it faster and get rid of the stuff you don't need. And there's still like a little bit of like unnecessary stuff, like you have things that are kind of confusing. Like you have this like mini, and you have an answer, and it's like, but your mini is your actual answer. So you know what I mean. So like I definitely would practice like do this one more time, and do it like faster and better. And then also don't have functions like recurse. I think that's like a pretty that's like a variable thing, red flag almost, you know, where like I think someone called their function like func. Like don't do that. Don't call function like func recurse. Also, yeah, don't have an answer when it's not the answer, you know, like things like that, because it's a little bit confusing for the person. Like if you have a variable called answer, I'd expect that to be like your output, you know, so things like that. Yeah, so I definitely think you were kind of on the right track. You just had the wrong, like you kind of picked the wrong DP thing. Honestly, for me, I don't even know the DP, like what are all the different types. I just kind of figure out like what do I actually need, and maybe that helps me more because I don't try to just pattern match like, oh, is it like, oh, one knapsack, is it this, because I don't even know what they are. And I more try to figure out like what do I actually need here, you know. And so basically, yeah, for DP, I would say something like, well, I need like the index. So my state would be like the index, and then I'd have a for loop here. And so this would be O(n) squared, and then like I'd get the height that way, and then yeah. And then this could be a lot cleaner. Like also you don't have like caching in here because we just like ran out of time. So things like that. So I think for the first one, I basically gave you like a lead no higher because you did technically have a solution, but it didn't have caching, and it took quite a long time. Okay. For the second one, honestly, I think I was kind of lazy picking the problem. Like I should probably just never ask this problem to anyone because it's like on the LeetCode 150, I think. So like everyone just knows this one if they did that. So, but granted that you figured out what you need to do right away, but once again, because it's a really common problem, I don't know if it's like you figured it out or you've just seen it. But I mean, I can't like, you know, take away points from that. So that was good. So the other thing you could have asked was you were like, oh, I have this map, and like it's concerning for me that I have to iterate through this map. So you could have asked something like, well, what are all the possible characters? And maybe I'll tell you like, oh, there could be like infinite number of characters, and then you probably need a better solution. But if I say like, oh, it's only capital letters, then it's like, well, I could iterate through the map because it's only of 26, which is constant time. So there is a solution where you where that is constant space, where basically the idea is you have like a matches, and then your matches is just the number of characters in B, and then anytime your frequency drops to 0, your matches like goes up, and then whenever matches is like length of B, then you know like you have the whole thing, and then whenever it goes from 0 to something else, right, to 1, then your matches goes down. And that way you could like not have to iterate through that. But I was like, whatever, like it's fine to do either one. But maybe some interviewer might push towards the other one. Like if we had more time, if you like crushed the first one, I'd be like, I'm not going to accept going through a dictionary. Do something better. But because we were running out of time, I was like, it's fine. It's going to be you know, only uppercase characters, and it's fine. So yeah. So the other thing here too, your code is a little bit hard to read because like what's flag? Like I don't know. And you also have some bugs. Like this wouldn't work because if your flag is correct, you can't just decrement one character because you might decrement a lot, right? So like imagine your things like ABC, and you have like n, 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 AB, like n, 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 c. Well, you don't just decrement the n, you would decrement like a ton here. And so this solution would just decrement one character and it wouldn't work. Does that make sense?
Yeah, but here we would maintain the min length window, right? So we don't have, since if we found, okay, yeah, if we found one min length, then it's better to traverse that window itself instead of decreasing. Okay, we are supposed to find,
So if
yeah,
you,
makes sense.
yeah, like, well, maybe it would, like, what it, well, let me see. So you do have a while loop technically. So like, so if you have this case, you would hit your flag, right? And then you would say, like, what would happen here, I guess, in this code? Like, this would be true. You would hit your flag, and then you would
Yes,
say, if this is less than min length, you would do some stuff, which
yes.
maybe it is, maybe it isn't. Um,
Okay, so
uh,
we are unnecessarily iterating through the map in this case.
so you are unnecessarily iterating the map, but like, would this even like give you the right solution the way you have it written? Like, maybe it
Uh,
would. Maybe I was just wrong.
yeah, it would, but this code would keep on running every time.
Oh, I see. Well, you kind of need the flag. Okay, so basically you're saying like, so okay, so this would calculate the min length, right? And then
Yeah,
this would do this would iterate the left. So if this is in here, okay, you're iterating the left no matter what. And then you're
we
getting,
are we are increasing the left only if we found the correct substring.
yes. So you would find a correct substring here.
Yes, so we
Okay,
it
okay.
would, the flag would be true until here. So
So okay, so when you increase the left, what would happen here? Like, what
yeah,
would
here,
happen with this part? Like, would you keep decrementing because the right stays the same, or no?
okay, so we are here at A, it would go false, right? The flag would be false
No,
after
no,
we
no, no.
put,
I'm saying like after one character, because your flag's an if, right? It's not a while. So like basically, let's say
yeah,
this is your window.
this is
So
my window,
this is
yes.
your window. So in the first iteration, you'll say like, well, my flag is true, so I'll do this, right?
Yeah, R would be at the same place.
Now
Yes.
you'll come back up here.
Yeah, the
Now
uh,
R is the same,
map
so you
didn't
would add it
change.
again.
No, the map wouldn't change
It wouldn't change. Okay, so how does that?
because I'm finding if the current character belongs to the map or not. So if it doesn't belong only, if it belongs only, that I would decrement the frequency.
Oh, wouldn't it belong? Because R is C, so that is in the map. Like the R
We are,
stays the same, so it would keep
yeah,
decrementing every time.
we are increasing the left pointer, right?
Yeah, yeah. But current car is the right, not the left.
Oh, that's the bug.
Yeah. So okay. So either way, basically, if it worked, but it was very confusing how, or it didn't work, it's almost the same thing. Because as the interviewer, like you can't run your code, so it needs to be
Okay.
very clear to me, ideally, like how this works. And I think the way you structured it, like, wasn't super clear. So the better way to do it would have been, like, at least usually the way I do it is you just loop through your right character, and then while your window is too big, you shrink it.
Yes.
Because here you had so many like different things. Like, I mean, also I don't know C++, so that's a little bit harder for me. But
Okay.
I felt like the logic was complicated enough to where since you can't run it, if I don't think it works, even if it does, that's like not good. So you want to have your logic like as simple as possible to make sure the interviewer's like pretty confident in your solution. Because I've honestly had that happen as well, where I knew it worked, but the interviewer wasn't sure. And the way you minimize that is by making your code like as simple as possible. Does that make
Yeah,
sense?
makes sense. Yeah, makes sense.
Yeah. So basically what I would have done is I would have said like always add the right character, and then basically here I'd have like while window too big, shrink. And then I know
Yeah.
for sure like this obviously works. But because you like had one and you had like a bunch of things all over the place, it was kind of hard to figure out exactly what was going on. And yeah, if you could run your code and like it worked, then I would like trust it. But here I was like, does it? I don't know. So yeah, basically I would improve on just designing this overall. And then yeah, I think for the first kind of the same thing. I would improve on like because you have like unnecessary stuff. Like I think for the first one this does work, but you have unnecessary variables that you basically never use. Like row width is always 0, for example, right? So you don't need it at all. Does that make sense?
Yeah, we could just, yeah, makes
Yeah,
sense.
so I think you want to have a solution, but you want to have a solution that's like readable and legible, and like the interviewer's like, oh, this is like I'm not getting a headache reading this code, basically, you know.
Okay.
So
Yeah.
definitely work on that. Like take a solution that works and go and like make it better. So I'd say for the second one, because we ran out of time, I mean, realistically in an interview, they probably just like cut you off, right? They're not going to be like, oh, we're over time, let's keep going. Um,
Okay.
so we were like a couple of minutes over. So I would say, and because it didn't work, I would say this is also kind of like a lean no hire, I would say. And this is basically like because the first problem you took so long, it's kind of like a it kind of leads into more like it's very hard to like go way over on the first one and then successfully do both, you know?
Yeah,
Um,
makes sense.
so I would say, yeah, basically, like make sure you don't go way over on the first one and then you successfully do both. Um, and yeah, so curious on your thoughts of like what like for this problem difficulty. I do also hear like I don't know what you're interviewing for. I hear a lot of people in my comments saying like, oh, in India it's like a lot harder. So I don't know if you're interviewing for like India or the US, but like how was this compared to what you normally do? Like was it too easy? Was it too hard? Like what do you think?
Yeah, so uh, I wouldn't say it's very hard in here, but yeah, the graphs and DP are very frequent questions. So most of
Okay.
the people don't do that. So for the first question, it's very, the one that I would want to have. Like
Mm-hmm.
it's like a proper one for man companies, I would
Mm-hmm.
think. But for the second one, I think this won't get asked unless it's like a smaller company.
I agree. I agree. Yeah, I think that's like my fault. Honestly, is asking stuff that's too seen by too many people. Because the other thing is like ideally when I do mocks with people, they'll just tell me they've seen it, and then I don't do that one. But no one ever does that. So
Okay.
everyone's like, oh, I'll pretend I haven't seen it, and like whatever. And then they have a solution in like 5 seconds, and then so I tend to ask stuff that's not like on any popular list, and I try to get more and more questions, but obviously like it's hard to keep getting more because I don't want to just ask the same thing to like every person. um, but yeah, so I think yeah the main takeaways here is just be a little bit more clean in your solutions, and yeah, you
Yes.
don't pivot from I think in the first one you basically said one thing and then you pivoted to another one because you realized it didn't work like that.
Yes.
I don't know if that's like a fail, but it's like pretty close to a fail, like you want to have a solution that like works and you don't need to pivot from ideally. um and then yeah, code it like cleanly and like stuff like that.
Yeah.
But I do think like your problem solving is like not too bad, and I definitely think you can clean a lot of this up. Just like think a little bit better, um, a little bit faster, and then yeah, work on making your code. I think that's like a really common thing. People don't focus enough on like having readable code with like good variables and all that kind of stuff. So basically, whenever you have solutions, try to take that extra step and like be like, okay, how do I take this solution and make it more readable and like better variables and like just take my logic and make it like easier to understand for a person, especially if I can't run the code and this person needs to think that it works. Does that make
Yeah.
sense?
Yeah, makes sense.
Okay. Do you have any other questions?
Yeah, not really. I just kind of did like a couple of problems, a pattern, so algorithm. So I haven't had many problems solved. I only have like 250 or something solved.
Yeah, so
So I covered,
I think for 250 this is a pretty good spot to be in. Like a lot of people with 250 can't do anything. So you're like almost where you need to be. I think realistically if you do like another 250, I think you'll be able to like crush this stuff.
yeah, so I'm able to recognize patterns, but not able to code them up in the right amount of time. So that's
Yes. Yes. And also you need
clean.
to recognize like you can't just recognize a pattern. You can't just recognize oh it's DP. You need to figure out like oh exactly what type, what does it need to look like. So you can practice a lot just writing like uh so I don't think you wrote it at all. So you can practice like writing like a little bit of pseudocode of like this is what I'm gonna do.
Okay.
And then consistently make sure that your code matches what your pseudocode was gonna do. So make sure like 90% of the time you write pseudocode, and then you don't have to like pivot all the time. Because a lot of people
Yeah.
rely on like I don't know what I'm gonna do. I'm just gonna start typing on leetcode and then I'll just like submit, and then whenever there's problems I'll just like redo it. And you can't really
Yeah.
do that, in interviews, especially if you can't run your code. So you need to understand, like, what am I going to be doing before I even write anything, and you need to be pretty confident in it, and it needs to like work.
Yeah, makes sense.
Okay, cool. All right, well,
Yeah.
I'll see you later, and best of luck.
Yeah, thank you.
Yep, see ya.